for section 2.4, continuity on one side limit. We already know that curve is continuous curve. It has no holes, break, and asymptote. So every time, remember what's the holes when we cancel? When we factor the polynomial on top, the polynomial on the bottom, and we cancel, this is the hole. Which is the same thing sometimes when you graph it, it looks like a gap or a break, okay? So this is, and asymptote, you have a vertical asymptote, especially the vertical asymptote. So that's mean the function, if there is no one of these, that means it's continuous, okay? As a math, a function f is continuous at the point C when it satisfies these three conditions. The first condition, f to the c is defined. That means when I plug in the point C on my function, just the function, not the limit, it's going to be a number, it's defined, okay? The limit when x approaches to the c for the function must exist, okay? That means there is a limit. And you will see the third condition, our limit is going to be equal to the function, to the f of to the point C, okay? That means the limit when approaches to that point is going to be equal to f of C. When you plug in the point C in your function, okay? So almost you're gonna get exactly the same thing. Let's see. What they're telling you. Here is the graph. Here's the graph. Now, the first thing they're telling you, the limit when x approaches from which side?
Right side.
From the right side. Tell me how much is going to be the limit.
4.
The limit equal when approach from the right side. So here is the right side to the point C. How much C? Okay, so don't confuse yourself. You can say, okay, how much is C? They're telling you here, C equal 5. So the limit equal when approach here is 5. How much the limit?
4.
4. You're gonna type here 4. What about from the left side?
4.
Also the same number, because here is the function. When x approach to number 5 from the left side, our y value approach to which number?
4.
To the 4. So also 4. What about the limit? You see from both sides approach to the same number.
4.
That means you're gonna type here also
4.
4. Is that hard? The graph, everything easy. So if you have, you say, okay, how I'm gonna do? Because sometimes there's no graph. You have two options. The graph a table. The second option is what? The graph the function. Go ahead, use the calculator, graph the function and check the limit. Don't stop on going, oh, I'm not gonna solve it. Because they're gonna give you only this one. No, you have option to graph a table, it's gonna be fine. The second option, graph the function. Go ahead, graph the function, and you're gonna find the limit approach to which number? From the right side, left side, right side approach to this number, and the same thing from the left side. Okay? We already know the limit equal what? So here is from the left side, and here is from the right side, here is the left side, and the limit equal 4. Now our limit is 4, which is this on the notes, on the instruction, which one is the second option? The limit equal 4. Now we have to check the first option, which is f to the c is exist. That means f, the c is 5. How much f to the 5? Which is the y point also equal 4. That means the third condition, our limit, the limit when x approach to the 5 to the f to the c equal also 4, which is our f of x. Let's say f to the 5. For both sides we get equal 4. That's mean we satisfy the three conditions. So now we have this graph. The first thing, at which point C equal -5. That means the limit when x approach to the C from the right side, how much the y value? Here is the function, approach from the right side, approach to which point?
5.
So 5. What about from the left side? The same thing, the function approach to the same number, which is 5. So the limit equal 5. Now let's check. This is the second condition. We found the limit. The first condition, f to the -5 equal what? You see? Here is -5. How much f to the -5? There is a hole here.
7.
So it's 7. So f to the -5 is 7. Is the third condition satisfied? The limit when x approach to the -5, f to the c is not equal f to the c. It means the function is not continuous. Okay? But they ask you, first of all, locate the point which is c equal 2. C equal 2. Now let's see the limit when the function approach to the c from the right side. Here's the right side. Goes to which point? From the left side.
2.
So you see the function here. The limit what?
Does not exist.
Does not exist. Do I have to check the other conditions? No, because the limit does not exist. That's mean one of these conditions not satisfied. So already it's not continuous. That's it. Copy. There is no graph. So when you graph it, check it from the left side. When c approach to the -9, equal what? So what about the next one?
The contrast is better.
Say it again.
Can you try turning off the front row lights so the contrast is better?
Because the video is gonna be down.
Yeah, so I could see.
So you can see it.
So I could see it, but I want to see if the contrast is better. That's a little better.
Okay. Wanna keep it? So when you graph it, they ask you only from the right side. The limit goes to which point? The limit from the right side. The limit when x approach the 6 from the right side for x -6 and x -6. That's the only thing they ask you. So again, you have two options until now to find the limit. Graph it. Can you simplify it? You can't, because there is absolute value here. So the limit from so you have two options: graph a table, create a table, or graph the function to find the limit from the right side approach to which point. Okay. The next example, what they tell you. Now they ask you discuss the continuity of the function. Now, remember what I told you. The first thing when they ask you, because the first option, we need to find the limit is f of c is defined. But did they tell you a point? Because I think there's a graph. Let's check the graph. Yeah. Let's discuss this one. That's the only thing they didn't tell you a point. The first thing, what are you gonna do? Do not look at the graph. Can I simplify this function?
Yes.
So, because we need to find the limit or continuous for this one of the options is there is the function which is x squared minus 4 over x plus 2. Now I'm gonna say f of x equal, I can use difference between two squares, so x minus 2 and x plus 2 divided by x plus 2. Can I simplify these? So f of x is going to be equal x minus 2. You graph it, you're gonna get this function. This line, okay? Check the point. X plus 2. Remember, this is what? This is what? It's the whole, which is x plus 2. That means x is going to be equal -2. There is a whole when x equal -2. So here is the graph. Check. Here is x equal to -2. Here is the whole. So there is a whole when x equal -2. So is that function is continuous?
No.
Why? Because there is what?
The hole in the graph.
That's it. That's what you're gonna say. Not here. If they give you this one on the test, you're gonna say the function is not continuous. Why? Because x, there is a hole when x equal -2. Okay? They're telling you f is discontinuous at x equal -2. On example 7. Consider the following. Find the x value in which f is not continuous. Which x value without using anything. Which x value to make the function not continuous.
0.
But when you plug in the 0, any number divided by 0. No. Any number divided by 0 is undefined. That means the first condition is not satisfied. Do I have to do the second one and the third one? No, because the first condition, when you plug in, when x equals 0, is going to be f to the 0 equal 4 divided by 0, which is undefined. So in this case, the first condition is not satisfied. That means when x equals 0, the function you should choose x equals 0. Now we're gonna go. If you have a whole or undefined, if the whole, that means it's a removable discontinuity. Okay, write down these notes. Like the previous example, you have a whole, right? You're gonna say it's a removable discontinuity. When x equals 0, what's that mean?
Non-removable.
It's not removable. It's non-removable. Why? Don't say it. Why it's non-removable? Think about that. X equals 0. We already know. The function is undefined. Okay? So it's non-removable discontinuity. Why? That's what we think. X equals 0. Is that a whole? I'm asking you, how are you gonna find the whole? You have to simplify the function, right? Like what we did on the previous example. When you simplify, the one you cancel it is going to be a whole. Did you simplify it? So it's what? You have two options. You have a whole, and the second one is what? To make the function not continuous. It should be a whole or what? Come on, the second asymptote.
Oh.
That's why this is an asymptote. Okay, you got it now? So when you graph it, It's an asymptote here. When x equals 0, it's an asymptote. That's why the function is what? Is not continuous. So when you have an asymptote, it's non-removable discontinuity. When you have a hole, it's a removable discontinuity. You got it? That's what you're gonna do. Just ask me. Let's go to the next one. What about the next one? Tell me. Consider the following. Find an x value which make the function not continuous. Now, can you simplify it? It's a rational, so you can simplify it? No. The second part. Do you have an asymptote? Yes or no? The asymptote only if you have a rational function. You don't forget that. The asymptote and the whole only when you have a rational asymptote. Sorry, when you have a rational function. So now, can I simplify it? No. Do I have an asymptote? No. So is that not continuous?
Continuous.
It's continuous. So what they ask you to type? It's a none. So you're just gonna type none. Because there is none point to make this function without continuous. So that means it's continuous. Yes. Find the x value in which the function is not continuous. Always, when you read the example, put a line what they ask you. The function is not continuous on which point? First of all, it's a rational. Yes or no? It's a rational function. So the function f of x equal 5 over negative x squared plus 4. So it's a rational. Before that, can I simplify it?
You can,
Okay, no, I'm talking about simplified to find the whole. You can't because there is only 5 on the top. Now, how to find the asymptote? That's my goal. Yeah. How are you gonna find the asymptote?
Plug in 0.
No, don't plug in anything. And we need to find the asymptote. I'm talking about this function. To find the asymptote, always set the bottom part equal to the 0. That's what I'm telling you. The asymptote exists only when it's rational. Because you're gonna take the denominator and equal to the 0. Can I solve this one? You're right, you can factor it, but it's negative sign. So you can't factor it here. You have to move to the other side. That means I'm gonna move this one. You're gonna to the other side, you're gonna add x squared to both sides. So maybe 4 equal x squared. Now what's the next step? I need to find the value of x.
Simplify it.
How?
Square root.
Take the square root for both sides.
X equals 2.
Careful. Square root for both sides. The square root of x squared is x. What's the square root of 4? No.
Plus or minus.
Plus or minus, don't forget that.
-2.
Plus or minus 2, okay? So the square root, every time when you take a square root for a number, put a plus or minus. So plus or minus 2. That means how many asymptotes do we have? Have 2 asymptotes. That means when you graph it, there's an asymptote at x equal -2. Again, an asymptote at x equal. So we have 2 asymptotes. These 2 asymptotes is gonna make my function is not continuous. Is that removable or non-removable?
No.
Non-removable. Why? Why non-removable? Why? Because it's an asymptote. Asymptote is non-removable discontinuity. A whole is going to be a removable discontinuity, okay? So you're gonna just put here the left and the right. Which one?
whenever you square it, why is it plus or minus?
Oh, okay, that's a good question. The first thing, when it's rational, check, can I simplify it? So you're gonna say f of an x. equal x minus 2 over x squared minus 4. Can I factor the bottom part? It's x minus 2, difference between two squares, so x minus 2 and x plus 2. Here's the thing. Where's the whole? Where's the asymptote? Cause here's the thing we're gonna do. Okay, I'm gonna find the asymptote. I'm gonna set up the denominator equal to 0, and you're gonna solve it. So you're gonna find two asymptotes, which is wrong. Which one you're gonna cancel it?
-2.
It's cancel. So that's mean x minus 2 equals 0. That means x equals 2 is what? I'm talking about this point, the one I cancel it.
That's a whole.
That's a whole, okay? It's not the asymptote. The one you cancel it, it's the whole, okay? You're gonna take it to the other side, you're gonna solve it, it's going to be a whole. What's the leftover? That's going to be the asymptote, which is 1 over x plus 2. So you're gonna go on the side again, you're gonna say x plus 2 equals 0. So x is going to be equal -2, it's what? It's an asymptote. So when they ask you here, if you put x equal -2, I think they're gonna ask you, it's a removable discontinuity or non-removable. X equal -2 is what?
Non-removable.
Non-removable because it's an asymptote. When you put x equal what? 2 is going to be what?
Removable.
Okay, perfect.
Why is it called remove?
You can redefine it.
Mhm.
You can what?
You can redefine the point.